Now, Euler sign integrals are a class of definite integrals in which I have the function as a log of a trigonometric function. So it's a class of integrals which are commonly asked in JEE Advanced, JEE Mains and IMO problems. And here we are going to learn a very general technique which you can apply to all such integrals. So whenever you have log of a trigonometric function and you have been asked to find its integral, use this technique and most likely you will be successful. So the technique goes like this. The first thing we do is that we give a value to this integral. We say that the value is going to be I. Okay, so this is the first technique. It's differing from our general method where we just do some integration, we find a function and then we substitute the limits of integration and find the value. That is not how we are going to do it. In fact, we are never going to actually evaluate the integral. We are never going to evaluate this integral in this case, and that is why this technique becomes so very powerful, because if you actually go about evaluating this, just doing the real integration here, the finding the indefinite integral, if you will not succeed. Okay, so that is the thing here. So what we do is that we assign a value of I here, and then we use a very general, again a very powerful substitution for all kinds of trigonometric problems, and that is x is equal to pi by 2 minus x. Okay, so if you have taken my class on Doris-Tutor, you would know that this particular substitution is very useful in evaluating several kinds. Okay, not only logarithm of the trigonometric functions, but several kinds of integrals dealing with trigonometric functions, and we have seen several such instances as we were preparing for the JEE Advanced. So here this is the integral that we are going to use, and of course if you evaluate this a little further, you will get this value. Now I also need to find out the new values of the limits of the integration, the intervals of the integration based on t. So I substitute the value of x as 0 and I get a value of t which is equal to pi by 2. So this becomes pi by 2, and I have substituted value of pi by 2 in x and I get a value of t which is equal to 0, and this becomes I is equal to log of 2. The sign of pi by 2 minus t will actually become cosine. Okay, cosine t, and then instead of dx I'll have minus dt. So I put a minus sign here and then I say this is dt. And of course, because there is a negative sign, what I can do is that I can reverse the intervals and get rid of this minus sign. So very nicely we again get back the same limits that were there in the original I. Okay, so this becomes logarithm of 2 cosine of t dt. Now next step, what do? We actually add these two integrals. Okay, so again very special thing we have here, very special step. So I do I plus I, that actually becomes 2i. So I write 2i is equal to, it will be an addition of this log and this log. Now whenever I am adding log, another thing I can do is that I can take whatever is inside the log and I can multiply those two things together. Okay, that is a very simple logarithm property that we are going to use. So this becomes 0 to pi by 2 log of 4 times, and this t and x right here, they are actually just the dummy variables. So they are just names, okay, if you will. So I just keep the name, instead of using two different names x and t, I am just going to keep one name which is x. I can always do that we also know very well. Okay, so this becomes 4 sin x cos x. And of course the dummy variable we have just chosen x to be our dummy variable now. So this t I actually changed to x while I was writing this. So this is of course 2i, because we have added these two together and we have multiplied the terms inside the log, which is a natural property of the logarithm, and the dummy variable I have now chosen to be x for my combined integral. So now another property that we have for sine and cos is actually, we know that 2 sin x cos x is actually equal to sin 2x. Okay, so that's what we are going to do here. That's why we wrote it like this, so that we can come to that terms. Okay, we can use this identity properly. So this becomes log of 2, and this 2 sin x cos x I combine, and I can write this as 2x dx. Now you can see that we are slowly and gradually we are trying to express our right hand side, this side, also in terms of I. Okay, and what that is the objective here. We are going to create, by writing the right hand side also in terms of I, we are going to create an equation in I and then going to solve for that equation. And again, very, very general and powerful technique for evaluating the definite integrals. We never actually evaluate the integral. We create an equation in I and then solve for that I. Okay, so that is what something that we are again trying to do here, and you see that we are becoming slowly and gradually we are becoming successful. We are coming back to our original integral I that we started with. Okay, the only thing missing is that here we have 2x and here we have x. So what do? We do another substitution. So what is the substitution now? Very, very obvious and very, very simple substitution. You will say that just do 2x is equal to t, and then we can write 2 dx is equal to dt, and of course dx becomes dt by 2. So we have to now write the new limits of integrals in terms of t. So I substitute the value of x to be 0, 0, and pi by 2. When I substitute the value of x, I get a value of pi. So those are my new limits of integration. And then we have 2 sine, and this becomes 2x just becomes t, and dx becomes dt by 2. So half comes here, and then there is a value of dt right here. So this looks very, very similar to our original integral. The only problem here is that we have a value of pi. The limits of integral, or the interval for the integration, is 0 to pi, and we need the value to be 0 to pi by 2. Now for that we use a property of this trigonometric function. So trigonometric functions, we know, have property that they are symmetric about certain angles, and that is the property we are going to use here. So what is the thing here? If you look at the trigonometric function for sine, so this is the trigonometric function for sine, we have it right here for you. And if you look at the trigonometric function for sine around this value of pi by 2, you will see that it is symmetric. What does that mean? It means that instead of integrating from 0 to pi, I can actually integrate from 0 to pi by 2 and then double that value, because it is symmetric about pi by 2, this the sine function. So what I can do now is log of 2 sine t and dt, and of course I need to double it, and I already had a half here, so this half and this cancel. And if you look at this integral, okay, and you understand that t and x are just dummy variables, you see that you quickly realize that, oh, this is nothing but I. So what does that mean? That 2i is equal to I, which means that I has to be 0. So without actually evaluating this integral, we found the value of this integral to be 0. And this is a very, very general technique. We are going to use, again, we are going to solve on this channel several problems related to logarithm of trigonometric functions, 2 or 3 problems, just to get you enough practice. So definitely subscribe, and of course these have been covered in detail in our lectures on DoorStep for JEE Advanced. So definitely go through those lectures if you still have confusion. Thank you.